In this video, we're going to learn what is called the power property. We're not going to prove it, we're just going to use it. So when we have, this is log base b of x to the a. You don't have to put parentheses here, but sometimes it's helpful to see that I'm taking in x all to the a. What the power property says is that if I have an exponent up there, I can bring it down in front of the logarithm and have good old multiplication. This is the number a times log base b of x. Let's do a few examples to convince ourselves that this seems reasonable. So 5 times log base 2 of 2. Well, I don't have to use the power property here. I know what log base 2 of 2 is. Remember, log base 2, what does it do? It takes in powers of 2 and spits out the exponent. Well, 2 is a perfect power of 2. It's 2 to the 1. Base of the log and the exponent are the same. What is this going to be? It's going to be 5 times 1, which is just 5. Right. So I did not use the power property here. I simplified log base 2 of 2 and said, hey, log base 2 of 2 is just 1. We've just got 5 times 1, which is 5. And in fact, I want to do arrows. There is no side to equality, right? You can bring this constant multiple up in front right there with the exponent, or you can bring this exponent down in front and just have a constant multiple. All right, so I've been using the blue for exponent a whole lot, so I just want to change this one to a different color because I want to underscore the power property here with the blue. So here, I want us to see that 5. Okay, so apparently 5 times log base 2 of 2, apparently I could have simplified that by bringing the 5 up in front and have 2 to the 5th power. Do you see that movement? And we can simplify this. Log base 2 of 2 to the 5th. Well, what does log base 2 do? It takes in perfect powers of 2, and it just spits out the exponent. The exponent here is 5. Done. The reason why I wanted us to do an example like this first is because we didn't need the power property to simplify it right here, did you? Log base 2 of 2 is just 1, and 1 times 5 is 5. But I wanted to do that to build some traction to see, hey, you know what? If I use this power property and I move that 5 up here, like it is right there, I, lo and behold, get the exact same answer. Let's do another one similar to this. All right, 4 times log base 3 of 3 to the 5th. Well, I could go ahead and bring that 4 up and have 5 times 4 is 20. But I'm going to go ahead and simplify log base 3 of 3 to the 5th first. I'm not going to use the property. Log base 3 of 3 to the 5th. Well, log base 3 takes in powers of 3 and spits out the exponent. That's just 4 times 5, which is equal to 20. And done. Okay. I could have brought that 5 down in front. Here we have 5 times 4 times log base 3 to the 1. 5 times 4 is 20. And log base 3 of 3 is 1. 20 times 1 is 20. Right? So on this one, we didn't use the power property at all. We just went ahead and simplified. Log base 3 of 3 to the 5th is 5. And went ahead and said, oh great, 4 times 5 is 20. Over here, we used the power property for this. What did we do? We brought the 5 down in front and had good old multiplication. 4 times 5 is 20 times log base 3 of 3, which is 1, and 20 times 1 is 1. We also could have taken, this 4 is a constant multiple. I could go ahead and bring that 4 up, and let's simplify this. We'd have log base 3 of 3 to the 5 times 4. We'd have log base 3 of 3 to the 20th. Log base 3 takes in powers of 3 and spits out the exponent. We're getting the exact same answer on all of these. So you might be saying, well, why do I need the power property? It seems like I don't necessarily need it. Like, why can't I just work the way I've been working like we did right here? Well, I've given us examples where we didn't need it to try to build some confidence. We're not doing a proof, but build some confidence that this in fact is true. I can bring these exponents down in front and have good old multiplication, or vice versa. If I have good old multiplication by a number, I could bring it up and have that number up in the exponent. Let's do one example where we have to use the power property. And you have one similar to this in your homework. 6 to the 2 times log base 6 of 4, right? So the base of my exponent here is 6, and then the whole exponent is all this. All right? The problem right now is that log base 6 of 4 isn't something I can simplify, because 4 isn't a perfect power of 6. But if I go ahead and I use my power property, and I bring that constant multiple of 2 up to the exponent, up here, we'll have 6 to the log base 6 of 4 squared. Why is that so nice? We've got 6 to the log base 6 of 4 squared. Well, what's 4 squared? I'm going to add in, not doing anything, I'm just going to add a new color to help. What is 4 squared? It's 16. And now we do have a perfect power of the base, right? 6 to the log base 6 of 4 squared is 6 to the log base 6 of what's 4 squared? It's 16. Oh yeah, 6 to the input and log base 6 of input do and undo each other. Answer here is 16. So on this one, I had to use that power property to simplify, because this log base 6 of 4 was something that I couldn't deal with. 4 is not a perfect power of 6, so I needed this property. Okay? I hope you found this video helpful.